All right, guys. Today we're going to talk about how you calculate a correlation coefficient, kind of. We're going to be a little bit disingenuous today. We're going to just pretty much use a calculator to do it for us. Frankly, based on the 8th grade level of math, they don't expect you to actually do this, but I just want to kind of give you guys a rough idea of the process. Even next year when we do this a bit more in 9th grade, you really just use a calculator and you just kind of do data entry. We will, God willing, if we get back to school at some point, we're going to do one by hand. We're going to do a kind of like a science lab kind of thing, where we'll take some measurements of people's arm spans and their heights, and then we'll write a correlation coefficient. So I do just want to show you guys, though, that there's some questions that could be asked you, and then kind of like what the numbers mean, which is really what we need to focus on, is like how strong a correlation coefficient is and things like that. So anyway, since Shannon's baseball card collection includes sets from many different seasons, her older sets seem to be missing more cards than newer sets. So she investigated to see whether this was actually the case. She has a lot of free time. She must be at home right now. For each set, she recorded the number of years since its release, X, so this is how many years it's released, and the number of missing cards, Y. Okay. This is what we call bivariate data. There are two different variables. There's the number of years that have passed, and there's how many cards are missing. Okay, so let's go ahead. Let's over here. We're going to add a few more. 1, 2, 3. Okay, so your X value. Okay, so let's go 7, and there were 17 cards missing. Okay, she had 11 years old. 19 cards missing. 12 years old, 7 cards missing. 13, 40, 27, 48. Whenever you're doing anything with data entry, the worst thing you could possibly do is put the wrong numbers in. So always double check. I got 7, 11, 12, 13, 27, 7, 17, 19, 7, 40, 48, 17, 19, 7, 40, 48. Okay? And essentially what you can do is you can calculate. Okay? And it's going to give you this number. Okay? So this is our correlation coefficient. It's a long string of numbers right here. They want it to nearest 1,000. So that's 0.756. Don't forget to round your numbers, okay? And let's talk about what that means, okay? This is a pretty strong correlation coefficient, right? We said your correlation coefficients go from +1 to -1. So this is pretty well on your way to +1, which means this. As the cards get older, there are more missing. And that kind of makes sense, right? The more time passes by, the more cards that will be missing. But again, that correlation coefficient shows you that this isn't a perfect relationship, right? If we were to graph these points, they're not going to line up on a perfect line. But there generally is a trend there, okay? Generally speaking, the more numbers you have and the more closer they resemble a linear relationship, the stronger your correlation coefficient will be. Okay. Connor is an ornithologist who monitors the wintering activities of birds in the forest clearing. He thinks that the number of different species arriving each season is related to the average winter temperature. For several winters, Connor takes a precise measurement to compute the average winter temperature in Celsius, so it's not Fahrenheit. And he also counts the total number of species Y that appears in the clearing. Okay. So Celsius, this is going to be X, this is going to be Y. I've got 1, 2, 3, 4, 5, 6. So I need to add one more. All right. So what do I got? I got 15, 7, 17, 6, 17, 10, 20, 7, 23, 8, 25, 10. Right? I'll press calculate, and it's going to say that the correlation is 0.46, which is not a very strong correlation. It does show that there is something there, right? But it's not as accurate as it is. So there might be some other factors besides temperature that influence the bird species, right? So it might be what if it was really cold, but then it was snowing and raining, right? So if it was a little bit warmer, but then it was raining real hard, the birds might not fly as much. So there's usually some way that you can interpret this data. But again, this is not a particularly strong relationship. Again, we want something close to +1 or -1. This is closer to +1, but it's not even like halfway there from 0. So it's not a great. Remember, 0 was kind of like no relationship at all. So there is a relationship here. It's just not as strong as we would think. Okay. So Lorenzo notices his bike ride to work takes longer on some days than others. He's curious to see how the morning temperature is related to the duration of his commute. For the past several mornings, he's measured the temperature in Celsius X and the times his commute has taken. Okay, so we have 1, 2, 3, 4, 5 numbers. So we'll reset this, and we're going to use 5. Okay, so what do we got? I've got -1, 50, 4, 44. If you guys are using a keyboard, the tab button in the top left-hand corner is a very fast way. I spent a few years working as a cashier at a grocery store, so I'm pretty fast at typing in numbers. We're going to calculate, okay? And it's going to give us that is a very strong negative correlation. That is a very strong negative correlation, okay? So that's -0.946, okay? So let's talk about that. That means as the temperature goes up, the time of his commute goes down, right? So in other words, he's able to move a little bit faster as the temperature warms up, okay? So again, like I said, I'll do one more, and then I'm just going to put this link. I'll put the link up here, and you guys go ahead and just use the calculator to find the answer to these. I said, hopefully, if we do go back to school at some point, we can do one of these together. We'll actually do an experiment, and I'll show you by hand how you do this. It's not too hard a process, but it is a lot of just fine details. So if I were to show you guys how to do it, you'd be spending a lot of time doing this. So 3. So a gym franchise is considering a television marketing campaign to increase its membership. The franchise's market research wanted to get a better sense of the television and exercise habits of the gym's target demographic. To begin the market, researchers surveyed some of the current members about how many hours they had spent watching television exercising last month. Using the survey responses, the researchers compared the number of hours of television watched to the number of hours of exercise for each member. Okay, so 3 hours of television, 49. 9 hours, 35. 11 hours, 47. So just right there, we saw these numbers went up and these numbers went down. These numbers went up and these numbers also went up. So we have a kind of a bumpy road here, okay? 40 and 33, 40 and 33. Okay, so I surveyed 2 people who had the exact same answer, okay? So when you calculate it, yeah, there's a general correlation there, yeah? So as these numbers went up, these numbers generally went down, and that's a pretty decent correlation coefficient. So -0.772. Please round your numbers correctly, okay? So anyway, give some of these a try. Let me know if you guys have any problems. This is really next year's work. I just wanted to show you guys kind of how we're going to do it. Next year, we're going to do it using the graphing calculator. There's a way for it to calculate the correlation coefficient, okay? So should be pretty straightforward today, guys. You plug in the numbers and press enter, okay? But give it a try and take a look at the numbers and let me know if you guys have any problems, okay? Thanks.